Hi, everyone. Can you hear me? OK, it's pretty cool. I'm just waiting for the slide. OK, so thank you if you are in the room. This is a really specific topic, I know. And I will do the best to give you the best knowledge what I can do today. So the main goal of this talk is to give you some sense of this universe where engineers, specifically front-end engineers working with video, are living in. Because basically, the reason behind this talk, because I started to give it on conferences, is that I think, personally, it's always really exciting to learn about some really specific corners of engineering, like WebGL for 3D graphics, or audio analysis, or just machine learning in practice. And you know, video has a huge piece on the market already. I mean, a really big thing, and everyone is predicting really amazing things about video usage. And it has a huge amount of code in the browser also. I mean, in the browser ecosystem, it's like a really big apple pie sitting there, and maybe you don't even know it that you have it in your hands. So if I have only one sentence to describe the situation of being a front-end engineer specialized for video streaming, I would use the analogy of Stranger Things, because it's like to live in a parallel universe where everything is the same, but nothing is the same. So we are using the same tools, the same frameworks. We are using React, we are using Webpack, we are using the same languages like Java on the back end and JavaScript on the front end. We are reading the same articles. We learn about the same mistakes. So everything is the same. But on the other hand, of course, there are some really dark corners. And at the end, you will end up reading the darkest corners of a WebRTC documentation, searching for an answer, and maybe you won't get it at the end. So it's a really hard thing if you start that. So what I wouldn't like to do today is to talk about the history of video streaming on the web, because we all know, preferably new, Flash. And I would say it's dead. We all know it. And it was a huge thing, but for me, it was the Demogorgon of the web, basically, because it was there. It was owned by one company, Adobe. It was a black box. It killed your CPU. We are just killing your CPU with JavaScript, but Flash killed your CPU 10 years ago, and everyone was writing everything in ActionScript. And the good news is that everyone realized it, especially Steve Jobs, that we had to kill Flash. And it's essential to point out that everything is the same. I mean, we are doing the same stuff in JavaScript what Flash developers did 10 years ago in ActionScript, and we didn't even necessarily use the knowledge what they had, and we repeated the mistakes with JavaScript. But the good thing is that at the end, everything is executed natively in the browser with JavaScript, and there is no plugin required. So there is one positive thing at the end. So when, let's say, 5-ish or 7 years ago, all the big browser vendors like Google announced that they will retire Flash in the browser, as a JavaScript engineer, I felt like, finally, I can write a JavaScript player, because I've done terrible things in JavaScript, and I would like to write a player in it, because it's so cool. And I was so passionate with the team at Ustream, which is IBM now. And then we had to realize that, OK, this is a dark corner of engineering for a front-end engineer at first time. So what I would like to clarify for today is that what I mean when I say video. Because when I say video, I think every one of you thinks about the currently running live stream, or a Netflix movie, or some streaming solution. But when I say video today, I'm talking about every kind of video on your web page. Like if you have a home page with a 10-minute small 10-megabyte video with your CEO talking, that's also a video. Or if you create the site of the day animation as a front-end engineer, and you have an MP4 at the background as a background image, that's also a video. So there are hundreds of ways to utilize video as a front-end engineer or as a product owner. So we are all using video at least once in our lives. So I'm talking about video in every aspect. And I think the second important point is that if this talk is interesting for you, and you decide that, OK, I would like to create a player, I can assure you that be careful, because it can haunt you in the rest of your life. It does with me. So the other question is that what is video technically? Because I think it's always really easy to forget that video is just a series of images, still images, played continuously right after each other. So if you have a 24 FPS stream or video, it's like 24 images played continuously after each other in 1 second, and that's a video. And these images are called frames. And I think it's really important to learn about keyframes before we go into the implementation details of a player nowadays, because keyframes are there because of some video compression stuff. So normally, of course, no one stores all the images in a video as a binary, because that's a waste of bandwidth and we need some compression algorithm or encoding in place. So that's why keyframes are the only frames which contain the whole amount of data in the current millisecond in a video. And the upcoming frames are just containing the delta, as you can see on the slide right now. So the first is a keyframe, the second one contains the delta, and then another keyframe comes at a later point, and then it contains, the next frames will contain the delta through the previous keyframe. And I wanted to point this out because I will mention it a lot today, and the only thing what you have to remember is that keyframe is important because that's the only point in the video where you can seek to. So if you have downloaded some video from somewhere and it was like a 10-second video and you've tried to seek there with VLC and it didn't work, that was because there was no keyframe in the video just in the beginning, at the end, and you are not able to seek. So if you would like to make a seamless quality change or something, you need a keyframe position to do that. So keyframes are really essential for that. So the question here today, because as I've said, I'm a front-end engineer and we are talking about the client side mainly, what do we have in the browser right now? Because we do not have Flash anymore, so we need something there. And of course, the first thing which crosses everyone's mind is the video tag. I mean the video HTML element, just like the image HTML element. You have an HTML tag, you write it, you specify the source, and it will play the content for you. And it's there, it's 10 years old now already. It survived a huge patent law war when every browser vendor tried to push their own container and codec combination to be the native container for the web. And it has a pretty cool support matrix. And the good news is that, of course, it provides all the events what we need as JavaScript engineers, so we can monitor everything, what's happening in the inside. We can know about seeking, time update, progress, and all the things what the user is doing with the native video element on the page. And of course, you can change it from the outside. It's not everything, but you can change the playback rate, for example. I always love to share this little hack with everyone, because if you are a conference movie junkie or something, and you are watching video players where they don't support the playback rate selector, like setting to double speed maybe, you can just open the DevTools and you can say document.query selector video, and you can change the playback rate to 2. And even if they don't support it on the UI, it will be a double speed video. And of course, you shouldn't try it with live because you cannot be faster than the current time on Earth. So the playback rate hack is pretty cool, and that's a cool demonstration that video is there in the browser, and if you open the DevTools, you can query it, you can change it, you can do whatever you want with it. So video element is really powerful. And the level 1 usage, what I guess everyone knows who is not using a streaming solution, is you set the HTML element in your HTML code, it will be in the DOM, and you just specify the source with a string, and you have one MP4, let's say, original or demo.mp4 on a CDN or an FTP, and you just specify it, and it will play it out. It's pretty cool. The only problem is that it's a really basic usage, and maybe if your server supports ByteArrays request, it will seek faster, because if a user seeks to one arbitrary point, then it will just simply load it with a ByteArrays request, but that's all what you can do with the normal video tag level 1 usage. The level 2 usage is, of course, when everyone tries to implement some accessibility feature or localization, you will end up using some subtags like the track tag, so you can put one VTT subtitle format into your CDN next to your video, and then you can specify the text track, and then the user will have the ability to turn on some English subtitle or Spanish subtitle or whatever you would like to do. And you can specify different sources for different browsers, because we are not in an era where every browser plays the same version, so we still need some codec and container combination on the server. But the result is the same. You will have a video tag, and it will play the content, and you don't have any special power over it. And the level 3 usage, I think all of you are familiar with the fact when let's say 2 years ago, last year, they fixed it with the presentation content what we are talking about today. But if you were watching an Apple keynote 2 years ago in Chrome or Firefox, you got a message, please go to Safari because this platform is not supported. And they didn't write this because they wanted to redirect you to Safari or something. The reason was simple. When they decided they would like to kill Flash, they introduced a new standard called HTTP live streaming, that's ageless. And specific browsers like Safari implemented the whole player needed to play out live stream in Safari. So if you see a stream where the video tags SRC is an M3U8, you are just watching a live stream or you are watching an ageless video in Safari or mobile devices. The bad news is that, of course, it's not cross-browser, so it won't solve any of our problems. Maybe if your only target is mobile, then you can do it. But that's all. The cool news is that they implemented all the features what we are talking about today, so there will be automatic bitrate switching, there will be support for multi-audio and everything. But of course, it's not working in Chrome. So this was the point where I thought, and everyone could think, that, OK, this is easy. I mean, I have the video tag. I can put some stuff to the server, and it will play it out, and that's all what I need. And that's true for basic usage. If you have a 5 megabyte video, you can do it, but we will talk about that later. So for real business, for real users, and if you have a really, let's say, medium-sized video, of course it won't work because you need some more special stuff. And I think we are all users here. We are all power users of Netflix, YouTube, Vimeo, and other platforms. And we have all experienced what we need in video playback. So if you are an engineer on the other side and you would like to implement something for the users, then you will end up having tons of features, and I will mention them. So when you start to dig into the streaming world, the first thing what you will notice is that there are so many acronyms, and if you search for one acronym, and you will end up with a definition with 2 other acronyms, and it's recursive stuff, and I think there is an end for that. So we should talk about the requirements. So we are all users, so I think it will be trivial for you, but I would like to mention because then we will talk about the implementation. So as an end user, I'm talking about myself, I would like to have a video stream with the highest available quality, ASAP, without any buffering, playing pretty smooth, even if my Wi-Fi is down. That's what everyone wants, and I would like the same. And of course, no one can do it, but as an engineer, we will try to do it. And it's not an easy thing because no one likes to have a black screen in an HBO episode, maybe. So what we need is, as an engineer, is to have a full control over the whole pipeline. So we have to control the startup time. We have to control the buffering. So we have to make sure that the rebuffering ratio, which means if the user starts the stream, you shouldn't end up in another buffering because the ratio will be really bad. We have to have control over that on the front-end JavaScript side. And also, we have to be able to change the source if the CDN fails or something. So it's a really big thing to control everything in the browser. And on the other hand, of course, as I said, we have to adapt to the user's internet connection. Like if the user is going to a subway station or something, then we should go down to the lowest quality because a 4K stream will start buffering pretty fast. So, and of course, I've mentioned the multi-language audio, like everyone tries to localize every stream. So multi-language audio, captions, subtitles, everything which is under the umbrella of localization and accessibility is really important for video, and you have to solve it somehow in your application, even if it's not a video streaming product. And personally, I think security is really important. Like, security is important for everyone in every product, but for me, if a video leaks, like an HBO episode leaks, it leaks sometimes, or a CEO talk leaks with some 10 seconds about the internal results of a company, it's a really big pain. I wouldn't say that it's a bigger pain than some user ID leaking or something, but having a video leaked about an internal meeting is a really painful one, and it's a binary, so it's really hard to talk about security here. And of course, I think it's really easy to forget about all the features, what you need in a player, like live streaming. Of course, it's a fully different animal because basically the stream itself is just growing right before the user, and if something is wrong with the incoming stream, then the user will end up buffering. So live streaming is a different animal. There is DVR, where you would like to seek back or pause the live stream, and it's like a continuously growing video, which is like a live stream. And of course, there is like multi-camera, where you would like to change the video feed without interacting the audio. And there are use cases like 360 players, virtual reality. So it's a huge thing. So one thing what you could realize already is that video tag, like I've demonstrated with level 1, 2, 3 usage, is not enough for this, because you have to be able to control what you do for the user. Like, you have to be able to decide what bitrate you would like to play. You have to be able to control the startup itself and everything, basically. So what we needed, let's say 5 years ago, was that we need to be able to download the content for ourselves, piece by piece, and feed it to the video tag. The good news is that Netflix and Google pushed it really hard with WebRTC, and they came up with a solution called media source extensions. The good news is that it's not a new thing. It's not like a stream tag in HTML or something. It's basically an extension for the video HTML element itself. And what you have to understand here is that they wanted to give the full power to front-end engineers, do whatever they want, and then the video tag will display it for them. So the quote here from WebRTC was like, allow JavaScript to construct media streams independent of how the media is fetched. So you need to get the ability in JavaScript to create media streams, and then you can play it out. So the first thing was changed, or changes, if you start to use MSE, is that, of course, you cannot store one MP4 on a CDN. Because if you would like to implement some automatic bitrate switching or something, you will end up transcoding multiple bitrates with multiple containers to support multiple browsers, of course, from the original media. And you are advised to separate the video from the audio and from the text, of course, because if you would like to, change seamlessly between Spanish audio and HD from SD and all the things, then you have to get them separated somehow, and then you can attach them together. I always use the analogy here, like if, when a chef starts to cook, everything is on the table, and then he can decide what he does with the current recipe. And I think it's really similar here. The player will decide what it wants to play. The only thing you have to do on the server side is like create everything. So with 1 gigabyte video, maybe you will end up with one file and 1 gigabyte, you will end up with 12 gigabytes of storage and thousands of files, because it will be different formats, different bitrates, and even it will be chunked into, let's say, 5-second chunks, because if you would like to do it continuously in the stream, you have to be able to load the next chunk with a different quality or different things. So it's like thousands of files sitting on the server. And go to the client side, because this is not a server-side talk. But it's a good point to understand that when you see a Netflix movie or you are watching the live stream right now, you have to think about thousands of binary files flying on a CDN, and the player is trying to figure out what's the best for you right now. And about fetching itself, you could also ask, like, if you are a JavaScript engineer, okay, how do I load binary data, because I've done it with images, but what's up with video? The good news is that there is no new API for that. You can use the same fetch API or the same XML HTTP request. The only difference is that you can specify the response as an array buffer, and the array buffer is an object in JavaScript to store binary data. That's all what we have to know for today. So that's all about fetching. It's like fetching a normal JSON response continuously from the server. The only difference is that a huge amount of data, and you cannot just print it to the console, because basically it's a binary media segment or chunk in itself. And here are the two main objects what were created 5 years ago, and it wasn't an easy ride in the beginning, because of course nothing was perfect, and it threw different kind of errors without a proper error message. So I could say it's kind of stable right now. So the first thing is source buffer. The only thing what you have to understand today is that source buffer is a storage for your array buffers, for your chunks. So if you have a video stream running right now, there is one source buffer for the video, there is one source buffer in JavaScript for the audio, and then the fetch algorithm just simply pushing the array buffer to these two source buffers, and it will handle every media-related stuff for you. So if you mess up the order, for example, you load the first chunk and the third chunk and then the second chunk, it will understand from the media metadata that they are connected, so it will play them in the right order. And the last thing what you need from now is a simple media source object, which is like a simple glue between the video tag and the binary data what you have. So here's a small example. As you see, it's just like window that set timeout. The only difference is that you say window.media source, and you create a new object, and you can specify it as a source for the video tag. And at that point, you have made the connection between your source and the video tag. And then, eventually in your code, you can just say, OK, I will use two source buffers, one for the video, one for the audio, and then eventually, I can load the data, the array buffer, and I can just push it to the binary. So that's what's happening in a Netflix player in every millisecond, basically. And as a result, if you are curious now and you would like to check your favorite player or platform about are they using MSE, you can just simply go to DevTools, search for the video tag, with the simple DOM selector, and if you see that the source is not a string, I mean it's a string but not a simple URL, it's an object URL with a blob, then you can be pretty sure that they are using MSE. And you will see that for YouTube, for IBM, Watson Media, for Netflix, for Vimeo, and for everyone out there on the market. So the real question is that, is it all what we need? I mean, MSE is there, it's pretty stable. Does it solve all the requirement lists to support every user right now with interactive movies like Bandersnatch and all the stuff? And as you could see, we can decide what to download. We know what bit rates we would like to download. We can figure out what branch from the Bandersnatch interactive movie we would like to catch and download because the user selected. And we can decide what type of content we would like to load. We can just say that, OK, we would like to load the Spanish audio with 4K. And the next second, you can decide that, OK, I would like to go down to SD, and the user changed to English, so I would like to load the next chunk with that. So you can do that. And the good thing is that you can do it without pausing, because in the level 1, 2, 3 usage, when you change the video tag source, it will just simply, flash a little bit. It will start the playback again, so you cannot change the source without a seamless transition, with a seamless transition. And with it, you can, because the source itself, it will be the media source. You don't change that source. The only thing you change is the binary in the media source. So the answer is, yeah. MSE solved everything. So we had Flash for media playback, and then they introduced an extension for the video tag, and it kind of solved everything in the client side. And of course, it seems easy if I show those examples. It's not that obvious, but those are the important lines there. And then you have a video tag with your binary data up and running. So MSE is pretty cool. And the only thing was changed is that previously, 10 years ago, we have said, OK, here, dear video tag, HTML tag, please, here's my URL, play it out for me. And right now you just say, dear video tag, here's my binary data, please play it. And I will do everything what I need to. So the question here, the rhetorical question for today, is this the new Demogorgon of the web? And I think we will see in, let's say, 10 years. But there is no Flash anymore. So I would like to go to the technical stuff, about ABR and how different companies are trying to achieve the same goal. So as a front-end engineer, a normal everyday objective is like, let's create a JavaScript player which loads the stuff from the server in the right order and fills the buffer, and then you have to make sure that it's smooth enough. And of course, you should predict the future of the user's internet connection. Everyone tries to do that, and maybe it will be possible someday. So the first question is, what's on the server? I've just shown you that there are thousands of files sitting on the server. But the big question here is that how the hell JavaScript figures out those files sitting on the server and the order or the media data and everything what's on the server. The good news is that you don't have to figure out your own solution like a JSON or GraphQL solution for that. There are two main standards to achieve it, and they are both based on media manifests. Media manifest files are nothing special. They are well-documented, structured documentation about a manifest file, which is like an XML-based stuff or something, and it describes everything on the server. So if you open a media manifest file for a YouTube video, you will just simply see every kind of resolution detail, what kind of quality they have, how many audios do they have, how many chunks do they have for one quality, what's the order of the chunks, what's the beginning and the end timestamp of a chunk. For the use case of Bandersnatch, of course, they have different folders for different branches, and then they have it somewhere in the manifest that, okay, there are 3 branches available. So it's about describing everything on the server itself. And here's just a quick example. It's a really huge file, and I wouldn't like to take so much time on it, but as you can see, in this current example, we have 4 chunks, for example, and you see it in the manifest that there are 4 media chunks. You see the length. So if the user seeks to the 25th second, you can just calculate, okay, the 25th second is like the 3rd chunk. So I will load the 3rd chunk and place it there in the source buffer. So the user has the chunk and I can play the content. So this is the one which is the most advanced, I would say. That's the Dash manifest, which is an XML-based standard created by Google, Netflix, and others. The bad news is that it's created by an industry forum and it requires a royalty fee for everyone. So that's why the industry is switching to another solution, which is the well-known old boy in the room, is the HLS, the HTTP live streaming created by Apple. So it's for the same purpose. The only difference is that it's not XML-based, so you have to write a nice regex parser in JavaScript. But at the end, you will get the same data, and it's free, and it will be amazing for describing everything on the server. As you can see on this example, I just highlighted that we have 3 resolutions right now for automatic bitrate switching, so you can decide what to load for the user. So these standards are for the rescue. And of course, not everyone here in the room or every engineer has a streaming stack at home, or they don't have a subscription for a streaming service. And the good news is that maybe you don't even need it. So if we are talking about a marketing page, or if we are talking about a simple video on your dashboard, you shouldn't necessarily have to get a full end-to-end solution. There are some open source tools like FFmpeg, Bento4, or Shaka Packager by Google, and you can just simply say that, okay, here is my one original MP4, and I would like to create 3 qualities, 2 audio qualities, and this is the format of the MPD, or the name of the MPD, and it will create everything on the server. And of course, it's cool for basic tweaks on your product, but yeah, if you would like to create some, if you are working with videos in your product or live streaming or something, this won't be good enough for you. But if you just excited about this talk and you decide at home that, okay, I would like to fine-tune the experience of our users, then you can just go there and pick those tools and create the content for the server side. So go to the client side again, because that's where I'm comfortable. So fetching is a cool question, like what to fetch and when to fetch, because I've said that, okay, we can fetch it. It's like array buffers and XHR. But the real question is that what to fetch and when to fetch. The what is pretty obvious because we have the manifest. So if the user seeks somewhere, you can just simply search for the array of the chunks and then decide, okay, this data should be there, and then I load that chunk and I go there. The what starts to be exciting when we go to the 4th point, when we talk about adaptive bitrate switching, because then you have to decide what quality, what branch of an interactive movie, or what kind of stuff you would like to play for the user. But the manifest will tell you the information about, when you decide what you would like to download, the manifest will tell you the information about what kind of chunk number exactly. The when is also exciting. If it's a small video, of course, you can just simply write something which loads every chunk immediately, and then you are done. Or maybe you can just simply use the video tag because it's there. It tells the same events for you. So if the user, here's a small representation, like if we have an MSC video tag and we have a video and audio source buffer, and in the beginning you decide, okay, I would like to load the first chunk for the video and the first chunk for the audio, then you can just simply listen to the time update event, which tells you like the user is playing the video. And once you realize that, oh, okay, I have only 1 second left in my video, then you can go and load the next one. And you can do that with the time update event. And of course, that's the same for seeking. When a user seeks, in a non-buffered place in the video tag, you will get a message, a time update, but of course it will be a buffering state, but you will get the same message. So you can go to the manifest, search for the location, and you can load the content, and it will play for the user. So if it's just about simply playing the video with one quality, it can be pretty straightforward. It's like, I don't know, 100 lines of code for a front-end engineer. So the fourth question is the adaptive bitrate switching, automatic bitrate switching, quality of service. It has a lot of names, but the reason is always the same. Like, everyone tries to play the content smoothly, and the user's internet connection changes a lot, and the CPU is throttled or maybe not. So you try to figure out what's the best for the user. And I think this is the point where we have to think about every video on the web. Because if you don't use an MSE or QoS or ABR-based player, you don't have it. So it's like if a user goes to your homepage and they just simply open it and you don't have it in place, then maybe they won't even be able to watch the video on a mobile phone in a subway. And it's a really important thing. So ABR is about, as I've said in the previous example, is about having multiple bit rates on the server. Like here you can see we have an HD and an SD, let's say, and we have an English and Spanish audio. And we do the same. There is a startup algorithm in place in every player. You can decide, like, you would like to start up fast with the low quality, or you would like to start up with the highest quality and the users will wait for that. It's a decision in your startup algorithm. Of course, everyone using some kind of machine learning or storing some historical data in the browser, but the end result is the same. They would like to replicate what the offering and product team designed for the startup algorithm itself. And the user starts to play, and when there is only 1 second left in the chunk, you just realize that, okay, the first chunk took 2 seconds for me to load, and I have only 1 second left, then maybe I should go down to SD, because maybe it will be cool. So you just load the SD, and it goes on every 20 seconds. So when you are watching HBO or Netflix or the current live stream, the player is doing the same. It tries to monitor the chunk download time, and it tries to figure out what's the best. And the live stream is also exciting here because, you know, you have only, let's say, 5 seconds ahead of you. So if you make a wrong decision, then, yeah, it will be a buffering for the user. Because for a VOD, for a video on demand stuff, you can just load a bigger buffer, and you can be sure that there won't be any issue with it. And if the user selects something, then you can change the Spanish audio. So it's about building the source buffer with based on different kind of decisions. And there are some best practices here on the market. Everyone tries to create some kind of constraints, like, of course, you have to use the fastest CDN for the current user. You shouldn't go to the US when you are in Europe or something. You should care about screen size. So if there is one user who is using a small iPhone screen, you shouldn't start up with a 4K because it's a waste of bandwidth, it's a waste of CPU, and the result will be the same if you use HD. So screen size is really important. And of course, CPU. And as you can see, the good news is that video is pretty smart. You can read the drop frame ratio from the video itself, so you can decide, okay, this quality is amazing, I can load it, but the user CPU is throttled because they are doing some data mining or something, and I have to change down to a lower quality because it will be faster for the CPU. And of course, there is the stuff what I just mentioned about internet connection, so you have to figure it out somehow. The bad news here, if you are a JavaScript engineer, you know it already, there is no API for that. So we cannot just go and query the window object saying, okay, what's the current connection of the user? The only thing you can do is like continuously estimate based on the chunk download time what you have, and that's all. So if the user is, I don't know, messaging or doing something in the background, it will continuously mess up your chart. So the only thing you can do is like gather some data, representative history, and try to predict based on these and decide, and maybe learn from your mistakes. If there was some buffering, learn from that mistake, and the next time you make another decision, or you use your data science team, and they will help out you with big data and machine learning and all the stuff what we can do nowadays to predict some kind of things based on user experience or user calculations. And at the end, everyone ends up with some A/B testing and measuring and trial and fail. So I think we have all experienced the changes in Netflix, for example. Back then, you know, they were always changing down to the lowest quality available when there was some issue with the internet, because the decision on the offering side was like, we shouldn't stop the playback. And they just simply changed it, and right now you can end up in a buffering, and they won't change down to the lowest quality. I've heard a story, I cannot confirm, but there were some solutions like if you have a cool internet connection, they always loaded the slowest quality and until the end of the video, so you can play the content without any problem if you have an internet problem, because basically that's there already. So there are different solutions and different white papers and articles about that. So at the end, the only question is that you have your algorithms in place and you can display your data, and you don't have to do anything with it, because, as I've said, the video HTML tag will understand what's in the media source, and it will show it for you, and basically you are done. And of course, there are some trickier features, like I've said, a 360 player, a VR player, or applying different kind of filters for the video, just like normal stuff what we do with images, for example. We should, or we want to do it with video. And the good news is that video is all about images. So what you can do with an image in the browser, you can do it with video. So there is an integration between Canvas and video tag. I don't know if you're familiar with Canvas, but one thing you should know about it, it's like you can do anything with Canvas in the browser. So if you create a canvas, and as you can see on this example, you continuously paint the current frame of the video to the canvas, then you are just playing a video in the canvas. So what you can do with the image, you can do it with canvas itself or the video itself. And that's the same for WebGL. So if you are creating a 360 player or VR player, from a player's client-side perspective, it's like the same. It's a simple stream, which is kind of weird in aspect ratio and kind of big, like a 4K. But for the player itself, it's just loading the chunks and it's putting there. And if you don't use WebGL or something, then it will be a strange video, with this Q effect in the video tag. But if you use the previous hack with Canvas and you use some open source library like 3JS, you can just create a sphere in WebGL, and you can project the video into the internal part of the sphere. You can place an internal perspective camera into the middle, and then if the user drag and drops, you can just simply watch the video. And if you do it continuously, then you will end up having a video playing in WebGL. So there is no impossible with video, since we have this kind of integration. And the final question for today, in your head maybe, if you liked my talk or if you didn't, why should you use MSE, and why should you even care about this whole stuff? And I think it's because you should utilize it even for the smallest video in your product. So the final message from me, just like I've mentioned it already, if you have a video as a front-end engineer, you can go to open source solutions. You can use FFmpeg or whatever to create the server-side content, and you can use open source players like ageless.js for ageless, dash.js for dash. And of course, there is Shaka player, video.js. So there are open source solutions to play the content. And if you need some end-to-end solution, you can use Vimeo, YouTube, or if you're an enterprise company, you can use IBM. It doesn't really matter. The only thing what I wanted to give you today is that that's important to care about user experience, and we always have talks about loading images faster, loading pages faster. We want to load everything faster, but we always forget the biggest chunk of binary data what we load on the home page if we have some video. So that's all for me today, and thank you very much.
All right, thank you so much. Let's see some questions real quick, because we're again late. So, why native HLS is not supported by all vendors? Is this a legal issue, like with some codecs?
Yeah, it's a cool question. I would say it's not a legal issue. It's like, if you are familiar with the browser vendors and their decisions, it's always about some kind of fight. Who wants to be the standard solution? And basically, Apple introduced HLS, and then the MSE direction came in, and that's basically invalidated the native support for HLS. Because what I've just shown you about the ABR and all the things, you cannot do it with direct HLS playback, because that's handled by the browser. You cannot decide your startup algorithm. You cannot do interactive movies, because it's like you give your HLS and it will play it. So I think it's maybe that's because of some kind of fight between the vendors, or it's just because MSE came 5 years ago and it killed it. So there is no need for that. And it's important that previously, for example, Safari supported only MPEG-TS, not MP4. and they started to support MP4 just to follow the trends of Chrome. So I think it's because MSC killed every solution, and MSC with MP4 is coming the standard right now in every browser. So but the situation is pretty cool right now.
All right. What do you think, what is the best practice to check if the browser prevents the unmuted autoplay?
Nice. I don't have the code in my head, but there is a promise-based solution for that. So if you go to the Chrome developer page where they announced that there will be this issue with unmuted audio and all the stuff, then they have a solution where you can query the browser if it's allowed or not, and you will get a rejected or accepted promise at the end. So I don't have it, but if you are here and you would like to get the answer, I can search it up for you. I will be here after my talk.
That's a nice way of saying, let me Google that for you. Okay, let's go for the last questions because we are out of time. Thoughts on security, intellectual property without DRM?
Yeah, so I didn't mention DRM because this talk was pretty tough without DRM itself. But of course, when we are talking about security with video, and we are talking about intellectual property like an HBO film or a Hollywood movie, then of course everyone is using DRM. For non-Hollywood stuff, there are of course different kind of encryption algorithms and different kind of hash-based, token-based solutions in place, and they are pretty cool too. But DRM is designed and created for Hollywood-grade movies, because it's about, you know, different kind of secrets and different kind of stuff burnt into the audio by the owner of the video itself. So it's a tricky thing. So yeah, DRM is the basic thing for Hollywood-grade stuff. And of course, there are other normal engineering ways to encrypt the video without DRM.
All right, thank you very much.
Okay, thank you.